What's going on? Backup channel oxygen unresponsive. Navigation system online. Propulsion system locked by external gravity field. We've been running for 6 hours and 17 minutes straight. You should rest and hydrate. Estimated water loss is about 400 milliliters. Just one more parameter adjustment. That one parameter you mentioned. It's happened 11 times in the last 3 hours. So you see, the 12th time was bound to happen. Oh. Xiaoguang, is the channel parameter for salary confirmed? Confirmed. Standard route, standard parameters. I could fly this with my eyes closed. Not recommended to pilot with eyes closed. Just making a comparison. How's the salary status? Parameters are normal. Plasma beam field strength is at 94% of the target value. Current state should succeed a few times. No issue with the lunar circle. Of all you said, that sounds the best. Initiating pre-jump check procedures. Navigation system is normal. Artificial gravity system is normal. Life support system is normal. Structural integrity is normal. Jump engine channel coordinates standing by. Route locked from Xinguang Point to Tian Port, standard route. Segment 7 channel. Zone deviation within allowed range. Alright, let's go. Jump engine running fine. Speed in the channel is steady. Estimated to reach Tian Port perimeter in 6 hours. I recommend you rest during the jump. What's happening? Detected anomaly ahead. Unstable wormhole in gravity field, not logged in records nearby. Exiting jump channel. Manual override digging. Manual override failed. Control system unresponsive. Switching to backup channel. Backup channel also unresponsive. Navigation system online. Propulsion system locked by external gravity. Hull stress exceeds safe limit of the casing. Deformation in the third section. Intake ducts ejected from engine bay. Preparing for flight. Yeah. Ejection. Vitals, heart rate at 62. Low blood pressure. AI diagnosis, communication module not recovered. You're awake, you have some nerve damage in your head. No cartilage fractures. Recommend treating wounds at SAP. Mothership confirmed completely destroyed. Xiaoguang. What time is it? Local time is about 1740. Calculated from planetary rotation parameters. Sunrise expected in about 10 hours. Survival pod navigation system. No astronomical data recorded during the fall. Deviation from normal region around Well Road is too large. Alright. Forget that for now. It's not Earth. Let's go. See what's left. Air is breathable. Oxygen about 19.3%. A bit lower than Earth's standard, but not harmful to humans. Temperature is 8 degrees Celsius. Still dropping. Radiation level normal. No toxic gases detected. Xiaoguang, connect to the Rex transponder. Tell me what's left. Connecting now. Connected. Scanning all systems, please wait. Jump engine is completely destroyed. Main propulsion system badly damaged. Remote communication system antenna cracked and destroyed. Navigation system online. Life support system on the edge. Mining robots, both intact. Usable. Basic toolkit, spare parts for a month. Emergency food, water recycler, medical kit. Calculate if I use everything carefully. Energy at minimum. Silent ration allocation. Full water cycle on. How long will these resources last me? Mushrooms can sustain food for about 180 days. If local food source is found, then no limit. That's enough. Survive first, then figure out how to go home. What's that? Spectral analysis shows characteristics of metallic ore in this area. Reflection suggests iron ore. Road is about 3 kilometers away. All right. Shaoguang. Nothing left in your hidden sea yet? Can't bring it out now. Stuff we might need in the future. There's a liquid furnace. It's pretty big. Needs to be disassembled on site. Some chips can be recycled. Room is full of markers. Let's talk about it tomorrow. Where am I sleeping tonight? Option 2. Front section of bone ship is unstable, plus traces of harmful gases. Option 3. Southeast direction. About 800 meters to a recessed rock wall. 3 sides covered. Ground is dry. Can be used as shelter. Take me to check it out. This is it. Shaoguang, does this planet have a name? It's not named by any known civilization yet. I'll just call it temporary for now. Let's call it 0. 0 as in starting from 0. Recorded current planet. Temporary code, planet 0. Shaoguang, what's the local time on the 25th here? Any warm clothing in the wreck? Forget it. Just tough it out. All right. Shaoguang, what time is it on Earth now? Based on star calendar conversion, Earth Standard Time is around year 187 of star calendar, 10 o'clock at night. My dad should be watching TV in the living room now. I wonder if my mom knows what happened to me. Lunar signal lost. Lunar rescue team should have left by now. But they can't find me. Jump signal lost. ID TF218703115 Pioneer and Industrial Mothership. Registered name, Trailblazer. Jump signal. During route from border trade station to Sirius relay. Suddenly disappeared. Confirm reason for signal loss. Detected abnormal energy fluctuation. It's a wormhole, but it's collapsed. Signal is completely gone. Wormhole collapse. Initiate emergency rescue procedures. Notify border trade station and Sirius relay station's rescue group. Have them leave immediately. Locate the accident ship. Yes. Report to command center. After wormhole collapse. No traceable spatial footprint left behind. Energy field in accident area is fully settled. Unable to locate accident ship. Keep searching. Expand search area. Command center, we confirm failure to locate the accident ship. Recommend handling as a cosmic traffic incident. Start family notification procedures. Who is this? Hi, is this Mr. Chun Jungwo? Yes. We are staff from the Interstellar Federation Accident Center. About your son, Mr. Chunxing? Mr. Chunxing was aboard the Pioneer, ship Trailblazer, on March 15, 2187 during the jump. He had an accident. Currently, we can't locate him. What do you mean can't locate? Where is he? How is he? Based on the rescue team's report, Pioneer had an accident during the jump. There was a wormhole collapse accident. The wormhole has completely collapsed. No trackable spatial trace was left. The rescue team searched for 3 days. Confirmed they can't locate the accident ship. So he's gone. Right now, it's treated as a space traffic accident. Legally, Mr. Chunsheng is considered missing. But if there's no new info in 7 years, he'll be presumed dead. What happened to old Chun? What's going on? What happened? Are you sure? Currently handled as a space accident. If there's any new information, we'll let you know right away. He even called me last week. He said he was at a border trade station. Sa'i was planning to head to Sirius Inspection Station. He said he'd send me special treats when he gets there. He can't be dead. He can't be dead. He was smart since he was little.
He took apart radios as a kid.
He couldn't put them back together. He cried all night. Next day, he tried again and fixed it. That's just who he is. He doesn't give up. But the wormhole collapsed. Even the rescue team couldn't find him. Not being found doesn't mean he's dead. He told me the ship he bought was called Pioneer. Pioneers are explorers. Explorers don't die easily. Which star is he on? Activate defense mode. Scanning for heat. Life form confirmed. Exact shape is unclear. Head is larger than average. Body is about 1.5 meters tall. 6 limbs. Front limbs end in retractable bone blades. Skin looks like dark gray rock. What the hell? Tentatively called Flame Beast. Top predator on this planet. They're locking onto us. Thermal sensors are scanning for hidden heat sources. No kidding. I'm burning like a furnace, Lil Light. What's the max range of the laser cutter? About 50, but effective range is under 10 meters. I don't need to scare them off. Robot 1 and 2, take turns firing laser beams. Don't aim directly, make bright flashes on the ground. They're testing if the lasers mess with them. But it's not enough to make them give up. Then crank it up. Robot 1, set laser power to max. Start maximum brightness. Warning, running at max power. Will reduce laser lifespan by about 30%. Doesn't matter, just fire. Igniter status. Robot 1's laser lifespan is at 62%. Robot 2 hasn't used max power yet. Laser lifespan is at 89%. 62%? We burned enough juice tonight to smelt 3 batches of iron. Let's head back and idle. Save power. Those 3 flame beasts ran off. But will they come back? Is this their hunting ground? Will this waist-high metal barrier keep out the next attack? They have no eyes. They hunt by heat. If those bone blades slice me, they'd probably cut my leg clean off. I still have 3 packs of emergency rations, 2 liters of water. Stretching it, that'll last 4 or 5 days. But after that, if I always need to use premium energy to chase them off, it won't last 6 months. I have to find something else. Can these tools make anything? Can I build a house? Can I build weapons? I need a new ship. The word new ship explodes in my mind, like a stone dropped in water. Being stuck doesn't mean waiting to die. I have tools. I have knowledge. I have a neural assistant. It holds tons of science info. Physics, metallurgy, mechanics. Everything.
If I can.
Build a full production system on this planet. Then maybe I can make a new ship. Sounds crazy now. But a lot of wild ideas in human history ended up coming true. Lil Light, what do you think? If I start from basic smelting tech, how long till I can build a ship that can fly? Can't give an exact estimate. Depends on many variables. Just give me a rough number. Rough estimate. If all goes well, it could take years. Or maybe never happen. Years? Lil Light, make me a list. What steps do I need to build a new ship? List recorded. Generating checklist. He's thinking first Lil Light. The device holds info on wild iron making. He checked it before. Remembers the ancients didn't have blast furnaces. No blowers. They smelted iron with primitive methods. He has all these resources. Or can find them. Lil Light, take me to the iron mine tomorrow morning. Suddenly, they didn't feel so unfamiliar. Maybe it's because he now has a goal. A goal he can stick with. He doesn't know if he can make it happen. But he knows. If he doesn't try, he'll never know. No idea what mom and dad are doing now. Let's go. No big creatures detected at night. Approaching mining robot. On alert the whole time. Lil Light, where's the iron mine? About 3 kilometers northeast. Route planned. Let's go. This is the starting point. I remember this place now. It knows this won't be its last home on this planet. That's it. Xiaoguang, analyze this. Spectral analysis complete. This ore is a mix of magnetite and hematite. Estimated iron content is about 62%. 62%. About 15% silica as a secondary component. Approximately 8% lithiophyllite. The rest are trace elements. Based on the surface outcrop size and the initial geological radar scan, this mine's reserves look impressive. Conservative estimate. Just the visible surface has hundreds of tons. There might be even more underground. With iron, copper, and coal, maybe we really can build a new ship. Xiaoguang, are the scan results ready? Based on the ecological scan, about 4 kilometers south of the mothership wreck, there's a forest. The plant xylem contains carbon. It can be used to make charcoal. Alright, what's my priority now? First, collect refractory rocks. Second, get coal. Third, build a blast furnace. Fourth, gather iron ore. Fifth, begin smelting. Let's go, grab the refractory rocks first. Xiaoguang, analyze. Spectral analysis is done. The rocks are high alumina sulfate type. Main component is about 45% lithiophyllite, around 40% silica. Estimated melting point is 1,650 degrees. 1,650 degrees is plenty. This works. Robot 1, switch to work mode. Laser cutter activated. This thing cuts are like a champ. Bit of a waste on monsters, though. 80 pieces. Should be enough for a small furnace. That's it for today. Recorded. Recommend resting well tonight. Your heart rate is showing signs of fatigue. Displays high fatigue level. Got it. Will this design work? Should work in theory, but there are a few issues. First, the quality of the refractory bricks. Bricks need to be bonded with refractory mortar. You don't have standard refractory mortar, you'll have to mix local clay.
Clay.
During the daytime scan, I think I saw a layer of yellow mud by the river. Yes, add water and mix for mortar. Second, blowing efficiency. Mining robot's air pump output. Power is enough, but the nozzle needs adjusting. If the airflow isn't fast enough, furnace may not reach 1,200 degrees. I'll figure this out. Tomorrow, when we build a furnace, I'll print a nozzle with the 3D printer. 3D printer welding supplies are limited. You only have 20 kilos of polymer left. I know, a nozzle won't need much. Third risk, temperature control. If the furnace loses heat too fast, or not enough fuel, temperature drops, smelting fails. So I need enough charcoal. After moving bricks tomorrow, I'll check out that forest, get some wood and make charcoal. Plan updated. Tomorrow's tasks. First, keep moving refractory bricks. Second, start building the furnace body. Third, collect wood for charcoal. Fourth, gather iron ore and get clay.
Added.
Let's try it. Nice. This wind speed should work. By calculation, nozzle output is about 30 meters per second, enough for full charcoal burning. In theory, let's give it a shot. That's it for today. Furnace loading tomorrow. Ignition the day after. Xiaoguang, check the furnace ceiling. Scanning the furnace body. Structure is intact. 3 tiny cracks found. On the north, southeast, and bottom sides. Recommend patching with refractory mortar. Knew it. The clay's adhesion just isn't enough. That should do it. Next up, furnace loading. Alright, start blowing. How's the temperature? Monitoring. Furnace temp rising. Now at 600,800, 1,000, 1,100, 1,150 degrees. Temperature rising. Slowing down now. Blowing efficiency looks maxed out. 1,180 degrees. Temperature is stable. Where's the issue? 2 problems. First, single mining robot's blowing isn't enough. Nozzle increased speed, but airflow is too low, so not enough oxygen. Second, furnace insulation isn't good. Brick thickness is only 5 centimeters. Heat escapes too fast. What if I make the nozzle exit bigger, say from 2 to 3 centimeters? That way, more airflow, wind speed will be lower, but total oxygen supply goes up. Should work theoretically. But you'll need to redesign the nozzle. Might need a bigger air pump too. If one mining robot's pump isn't enough, what if I link 2 robots' air pumps? Yeah, you can link them. Total airflow would double, but you need a Y-shaped connector to merge both air streams. Alright, let's do it. I'll redesign the nozzle. Make the exit 3 centimeters. Then 3D print a Y connector and link both mining robots' pumps. There's still one issue, furnace insulation. Bricks are too thin. I can wrap another layer. What to use? Ordinary rock works. Its melting point isn't as high as the bricks, but it'll insulate well enough. You can add a layer of regular bricks outside. Leave a gap between the 2 layers. Fill it with ash or crushed charcoal. That'll boost insulation a lot. Good idea, like double glazed windows. Air layer in the middle keeps it warm. Let's change the plan. Redesign the blower today. Upgrade the furnace tomorrow. Try again the day after. Gotta eat first. Can't work on an empty stomach. Once we get some iron, I'm definitely making a pot. Sick of eating this stuff every day. My stomach can't take it. Xiaoguang, check it. Scanning the furnace body. Structure is intact. Insulation layer is 5 centimeters thick. Insulation material is evenly packed. Blowing system upgraded. Total airflow up about 80%. Furnace temp now can reach over 1,300 degrees. Let's try again. Monitoring temperature. How's the furnace temp? It's rising. Currently at 600,000, 800, 1,000 degrees. 1,100, 1,200, 1,300, 1,350 degrees. Temperature keeps climbing. Now it's above iron's melting point. How's the furnace inside? Scanning now. Ore is melting. Molten iron is collecting. Currently about 2 kilos of iron. Is the iron outlet ready? Ready to go. Casting mold placed under the outlet. Someday I'll go back. Yeah, you'll go back. Energy daily, backup energy module remaining charge 87%. At the current rate of consumption, mining robots routine inspection costs about 3% daily. The smelting furnace uses around 5% of power each run. 3D printer uses about 2% each time. Life support system uses a steady 0.5% per day. Estimated to last 5.3 months. 5.3 months. So until the end of August. All power runs out. Yeah. At this rate, I don't even have time to finish building the base. How big is the translation? Solar power issue. The main star of this planet is a K-type orange dwarf. Its light is only 60% as strong as the sun's. Plus, the local weather is mostly cloudy and rainy. And with the solar panels you have, the generated power barely helps. Plan B, wind power issue. You need a generator. You need permanent magnet materials. You can't make the copper coils for a generator. No wire drawing equipment. Plan C, burning coal for steam power, then generate electricity. This is the most realistic route. Coal reserves are rich. Steam engine principle is simple. It can drive machine tools and make precision parts. But the problem is obvious. Building a steam engine itself needs energy. You need to cut metal, cast parts, and make sealed surfaces. It's a chicken and egg deadlock. I need electricity to make a generator, but I make a generator to get electricity. Isn't that just crazy? Shelter is pitch black inside. Only a few clusters of fungus on the rock walls give off dim blue light. Xiaoguang, I've got an idea. I don't need to build a full steam engine. I just need to make the smallest one, a steam unit that can generate power. I'll use the remaining electricity to build it. Once it's done, it'll supply its own power. No more relying on backup energy. So I'm trading 6 months of power for an energy source that doesn't need power. It's an investment, not consumption. If the design's right, Making a small steam generator will cost about 15% to 20% of the current backup energy. Success depends on machining precision and density. Trade 20% of power for infinite possibilities. Let's do it. Time won't wait. It's a last-ditch gamble. Cylinder wall thickness has to be precise to microns, or it can't take high-pressure steam. Machinery. The spark of civilization is reviving line by line in this data.
Done.
Basic structure finally works. Starting tomorrow, I'll build a steam engine from scratch. Sounds like a crazy dream, right? According to historical records, the human industrial revolution really began as a bunch of crazy dreams. From this moment on, I'm no longer a passive survivor. I'm an engineer rebuilding civilization. Half a millimeter left. 0.3 of a millimeter left. Checking if it meets the standard. Over-repairing. Cylinder isn't airtight enough. Please watch equipment safety. There's still a chance.
Done.
Machining the first steam parts with a simple lathe. Build a steam engine with these parts. Use the steam engine to drive the lathe for more precise parts. Parts completed 100%. Next step, final assembly. Assemble, then fire it up. No ratings for appearance. Structural integrity 82%. Sealing performance 76%. Estimated electromagnetic conversion efficiency 35% to 40%. 35% would be insane. As long as it makes money. External power detected. Input voltage steady at 220 volts. Frequency 50 Hz. Got internet access. This is only the first step. April 5th, 2187. New calendar. Pioneer base starts generating steam power. Generator output, 2.1 kilowatts. Base enters the steam age. This is just beginning. Another day. Can't stay here anymore. Need to find a new place. Time to move. Smelting area is on the north side. Smoke goes out downwind directly. Quenching wastewater flows into the settling pool. Living area will be on the south side. Keep a 50-meter safety distance. Must block out some noise. Processing area and energy zone in the middle. Xiaoguang. Should we make it systematic now? Check out the surrounding environment. Suggest recording everything within 5 kilometers of the base. At least 12 kinds of animals. And various mineral resources. Systematic survey will help uncover hidden resource value. Let's start today. Let's name this survey. All things arrive. Xiaoguang analyzed this. This plant's fiber strength is close to steel. It's also very flexible. If it's collected and processed on a big scale, it can replace some metal parts. What's more important, it grows really fast. After harvesting, in 3 days, it can grow back to 1 meter high. It's basically a biological steel. That's awesome. I was worried about not having enough iron. I'll call it iron grass. This fluorescent fungus glows super efficiently. Converts electricity to light at 3 times ordinary light sources. If we can understand its
Glow mechanism.
maybe we can develop new light sources. Pulp contains up to 60% oil. Calorific value is close to diesel. It's like a natural gas station. I'll call it oil fruit. Contains traces of titanium and vanadium. If we can extract them, can make high-strength alloys. This is ideal for high-temperature ceramics. Finally found it. Suggest building a structured database, so it's easy to search and link later. Let's call it One-Star Encyclopedia. Even if it only has a dozen entries now, one day it'll become a big book. April 22nd, 2187. New calendar. I'm a lost person, stranded on an unnamed planet. No humans here. No cities. No roads. But there's minerals, water, and life. I built myself a home here and started learning about this world. This book records everything I see. Maybe someone will read it someday. If that someone is me, hope I remember the early days. How strange this planet was, and how generous it is. Detected massive biological migration. Heat scan shows about 40 to 60 large creatures are moving toward the base from northwest, about 3 kilometers away, moving at around 5 meters per second. At this speed, should reach the base in 4 hours. Yenli beast. Based on biological features, it's a Yenli beast, herd migration, probably due to season change or food migration. The problem is the migration route passes near the base. Activate defense plans. Defense protocol initiated. Open fire. Hi. Heart rate dropped from 162 to 95. Suggest resting. No rush. Fill the traps first. Used 8 bottles of oil for Molotovs. Need to refill them. And fix the wall. Raise it to 3 meters. Xiaoguang, after I leave, I'll leave the base to you. Auto monitoring set. Stay safe. Base is all good. Steam generator running steady. No signs of big creatures outside the wall. I don't feel bored, but if you're not here, my processing. Resource efficiency drops 337%. Maybe that's what you humans call quiet. 50 kilometers. Only gone less than 20 kilometers. Still a long way to go. Subsurface heat gradient is oddly high, possibly active magma underground. Geothermal anomaly means rare minerals may be concentrated. Volcano activity means stuff rising from deep crust. Lots of rare elements might reach the shallow layers. Deep in the cracks, large ore deposits expected. Confirmed nickel laterite, about 3% nickel content. Key element for heat-resistant alloys, vital for smelting equipment upgrades. Detected high-purity tungsten mineralization. Tungsten melts at 3,422 degrees. Perfect for making high-temp gear. If we can mine and use it, iron, nickel, tungsten. This planet has more resources than I thought. Turns out here. If only there were 10 people. No, 5 people would do. 1 for mining, 1 for transport, 1 for smelting. 1 for logistics, 1 for research. Just me then. Step by step. Mark all the off spots first. Solve them one by one when I'm back. Coordinates locked in. Mission complete. Heading into the mountains tomorrow. Tomorrow I'll go in. How's the radiation toxicity, Xiaoguang? Background radiation here is a bit higher than the base area, but it's still within safe limits. Surface radiation dose is about 0.3 millisieverts per hour, mainly from natural radioactive elements in the strata. Radiation. Abnormality detected ahead. Gamma ray dose rate is spiking from 0.3 millisieverts per hour, jumping up to 12 millisieverts per hour. We've entered the red alert zone. As a space citizen, he's already registered for the Windbeast gene vaccine. Otherwise, he couldn't do space pioneering. His tolerance for alpha, beta, and gamma rays is nearly 10,000 times higher than humans back in the planetary era. Bitumen oil deposit. High purity estimated natural oil content is over 70%. This vein is pretty big. It extends at least a dozen meters. Xiaoguang, what's this? Unknown mineral. Spectral feature. Doesn't match any known mineral database. Suggests detailed analysis. Xiaoguang, activate material composition scanning module. Full spectrum analysis. First abnormality. Element makeup. Main components are silk, B, lead, magnesium, silver, and copper. All are known elements, but the ratio is unusual. Also detected trace amounts of unknown element. Let's call it X7, about 0.3% of the total. It's unevenly distributed, concentrated at interlayer bonds. Second, the highly ordered layered microscopic structure. Cross-section scan shows. The crystal has 7 layers made of submicron coatings of different elements, stacked alternately. Each layer is 20 to 200 nanometers thick. Layer interfaces are clear. No detected misalignments or defects. Means it formed with slow cooling and under extremely high pressure, probably from millions of years of hydrothermal activity. Each of the 7 layers is different. Yeah. Third, rare thermoelectric properties. Seebeck coefficient measurement. Between 300,000 and 800K. Average coefficient is 850 microvolts per Kelvin. Way higher than known silk-walled materials at about 200 microvolts per Kelvin. More importantly, its heat radiation sensitivity is super high. Infrared absorption rate is over 92%. Fourth, full spectrum responsibility. Material responds from near infrared at 0.8 microns, all the way to far infrared at 20 microns. Shows strong photoelectric response throughout the band. And the peaks in different bands match the layer compositions exactly. That explains the real purpose of the layering. Each layer targets a specific wavelength range, so it captures the full spectrum. Each layer absorbs a chunk of wavelengths. So this isn't just a simple thermomelt material. It's a full spectrum heat radiation catcher. Fifth, reversible cooling mechanism.
Temperature simulations show.
When the crystal absorbs heat above a threshold, its internal carrier concentration surges. It releases excess energy as photons by boosting radiation recombination. That's how it sheds heat. And it's a bonus way to output electricity. In short, the hotter it gets, the more power it generates. If it gets too hot, it glows and cools itself down. Is there more? Yeah. Sixth, growth marks. For the outermost layer of the crystal, isotope tracing in the new crystal region shows the X7 element is part of a process like radiation-catalyzed crystallization. The mineral's spontaneous decay emits alpha particles and gamma photons. When they pass through the crystal's surface, their energy is absorbed by X7 atoms. It turns into local vibration energy that lowers neighboring atom migration and forms ordered energy rods. Put it simply, in short, radiation itself drives its crystal growth. Without radiation, it hardly grows. Stronger radiation, faster crystal growth frontier. Seventh, historical growth record. Layered structure in the crystal's cross-section isn't just simple stacking. Every coating layer records the radiation intensity at the time. Like tree ring spacing, wide rings mean high radiation periods. Narrow rings mean low radiation periods. This crystal is a natural oil field decay diary. It records this planet's millions of years of geologic activity. Xiaoguang, give me a summary. It's a natural triple converter for heat, electricity, and light. It can turn heat radiation right into electricity. Plus, it absorbs the whole spectrum and has self-adjusting cooling. If you collect enough crystals and link them up, any heat source, campfire, geothermal, sunlight, even engine waste heat, can be turned straight into electricity. No need to burn fuel, no need for turbines, no moving parts needed, just temperature difference and radiation. If this thing's conversion efficiency is really that high, steam generators could be obsolete. No, not just obsolete. It's a leap forward. Skip the steam era and jump to solid-state thermoelectric. Xiaoguang, record the coordinates. Mark this as mine site 7. Change it to thermoelectric mine site. Top priority now. Coordinates recorded. Suggest collecting enough crystal samples and return to base for systematic testing. Need to recalculate everything after we get back. Energy wave abnormality 3 kilometers ahead. Chunxing checks orbital scan data against real-time readings from the portable spectrometer. There's a heat source signal deep in the valley ahead. Doesn't match any known mineral database. High chance of unknown special minerals. Roger, keep navigating. Let's go check it out. Suggest caution. Cave structural stability unknown. Atmosphere inside needs more testing. That energy reaction is intense. Morning star's crystal structure shows a super rare superconducting characteristic. At room temp, its electron mobility is 50 times higher than copper. With proper processing, theoretically, it could stay superconductive at much higher temperatures than usual materials. Achieve superconducting state. So you're saying, if we can use this mineral's properties, technically it could be used to make room temp superconducting coils. Room temperature coils are core parts for high-efficiency jump engines. That's what we need to fix the ship. That's it. Energy stable. Structure unstable. Recommend immediate retreat. Go. Uh, uh. See, I found it. Superconducting mineral in the sample, temporarily named new silver. Room temperature electron mobility confirmed with multiple tests. Data is reliable. If we get enough new silver and succeed in melting and refining, fixing the lunar jump engine won't be just wishful thinking. Worth it. So worth it for us. Xiaoguang, first talk about the nuclear energy crystal. Okay, based on the last 2 days of test data, I've designed the prototype thermoelectric generator. The principle is simple. Connect thermoelectric modules in series. One side touches the heat source. The other side connects to a heat sink. It uses temperature difference to generate electricity directly. What's the heat source? Anything works? Campfire, geothermal, even focused sunlight. But I recommend using the base's steam boiler. Take advantage of the boiler's built-in heat source. Just use the excess heat from the boiler and send it to the thermoelectric array. This is the key to the stars. Start the boiler. Voltage detected. Current open circuit voltage, 14.7 volts. Short circuit current, 2.3 volts. Output power is about 34 watts. 34 watts isn't much, but that's with just 50 modules. If we bump it up to 200, 500 modules and crank up the boiler, current output is 127 watts. Voltage is steady. Current rises linearly with temperature difference. Connect the thermoelectric array to the base grid. This is a critical moment. If the thermoelectric generator can keep power steady, it might even replace the steam generator. The grid is working. The thermoelectric generator is handling the base load. The steam generator can now be put on standby. If I build an even bigger thermoelectric line, The output could reach 1.5 kilowatts or more. That's enough to start up the ship's smart smelter. Smart smelter. That's the Starship's most advanced equipment. It can precisely control temperature, atmosphere, and pressure. It can smelt almost all known metals. But it's been idle because the base doesn't have enough power to run it. Current output, 1.8 kilowatts. Voltage is steady. Frequency is steady. Start up the smart smelter system. Heating elements are working normally. Vacuum system is normal. Atmosphere control is normal. Equipment is ready. Begin drill program. Target temp 3500 Celsius. Ramp up 50 Celsius per minute. The new silver ore is fully melted. Current temp, 3500 Celsius. The liquid is stable. Recommend moving on to impurity removal and casting. Xiaoguang, make a note. May 14th. Stellar silver ore smelted successfully. Next up, batch smelting. Making superconducting coils. Noted. Also, according to the spectral analysis during smelting, I found some interesting things. After melting the stellar silver, or a layer of gray-black slag floated up, spectral analysis shows. These are impurities from the stellar silver, or mainly oxides of silicon, aluminum, and magnesium. So basically, the metal liquid we got is pure. Stellar silver still needs further refining. How do we refine it? Two options. First, add a flux. Let impurities form slag that's easier to separate. Second, use chemical methods, like electrolytic refining. Refine it even further. Electrolytic refining. That means casting stellar silver into an anode. Put it into the electrolytic cell and power it up. Right, but the electrolyte choice is tricky. Stellar silver has super stable chemistry. Regular acids might not dissolve it. So starting tomorrow, we'll systematically test different electrolyte recipes. Smelting is just step one. Refining is the real challenge. At least we're on the right track. Not even nitric acid can deal with it. What the heck are you? Successfully dissolved phosphorus. This stuff is basically unwilling to react with any chemical. "83 tries. 83. Still no decent result. Xiaoguang, do you think I'm going in the wrong direction? Maybe chemical extraction just isn't the way? Based on current data, stellar silver's chemical inertia is way beyond normal. But during experiment group 7-9, the observed pseudochemical assisted decomposition shows that under certain conditions, stellar silver's phosphorus structure can be disrupted. So the direction is right. We just haven't found the right method yet. Are you trying to comfort me? I'm just stating the data. True. What if we change the conditions for that chemical aid? No need for AC. Use DC, skip regular solutions, use lava instead. The temperature for lava electrolysis, usually between 150 degrees Celsius and 10 degrees Celsius. Detected trace dissolution on the anode surface. Silvery ion spectra appeared in the lava. Finally, something happened on the 84th try. The 372nd experiment succeeded. Sample analysis complete. Purity is 92.7%. Main impurities are tiny amounts of iron and carbon. Room temperature electron mobility is about 38 times higher than copper. It's good enough for superconducting applications. 92.7% isn't perfect, but it'll do. This document's worth a gold mine. Xiaoguang, do the math. How much superconductor do we need to fix the room temp coil for the jump engine? How much superconducting material do we need? Based on the shadow design specs, we'll need at least 5 kilograms of high-purity superconductor. If we count the processing losses, we should prep 8 to 10 kilogram. With 300 grams, we need 5 kilograms total. At our current output rate, we need about 35 kilograms of new silver ore. But inside the mine, the entrance is about 2/3 blocked by a cave-in. There's around 30 meters of accessible space left. From what I've seen, the new silver crystal supply is estimated to be between 50 and 100 kilogram. If we clear the entrance and expand the tunnel, there should be enough, or... So basically, materials are covered, but that mine needs to be reopened.
It's a big job.
That's enough at least. We're heading the right way. Now we have a material source and a plan for the process. Next step is scaling up and boosting production. New calendar, year 2187, day 65. Success on batch 127. Superconductor extraction finalized. Ship repair went from impossible to hard but doable. The thruster's design is more complex than I thought. Start with something simpler. The assist thruster system is way simpler than the main engine. If I can't even fix that, there's no way I'll fix the main engine. Every smelting session faces the unknown. It's been 3 days. Every second of waiting feels heavy at moments like this. Every coil wound brings us closer to the unknown. Yeah, it's kind of ugly, but this is the first real high-tech product on this planet. At least it can run one more time. Xiaoguang, start the sequence. Pre-check for thruster system started. Superconducting coil resistance is near 0. Energy input circuit checked out. Nozzle points forward and locked. Safety check. Nothing within 500 meters. It worked. Assist thruster system started successfully. Thrust output at 42% of rated power. Limited by the coil's max load and energy input limits. 42% is enough. At least it proves we're on track. Assist thruster system works. But the main engine is a bottomless pit. 5 kilograms of superconductor, a 5-axis precision lathe, a huge burst of energy, and way too few hands. We'll go one step at a time. First, solve the material problem. Each of these steps means a ton of mining, smelting, processing, and assembly. And it's just me here, plus 2 mining robots, 4 specialized bots, and the AI Xiaoguang. If I want to boost output tenfold, how many more robots do I need? If mining and hauling go full parallel, the whole workflow running at once, I'll need at least 30 specialized robots. That means 8 mining bots,
10 haulers,
6 processing bots, 4 assembly bots, and 2 inspection bots. I've only got 6 right now, so we're short by 24. I know how big the gap is. The problem is making them. With a CNC and 3D printer, I can make most of the hardware. But there are 2 big bottlenecks. First is the joint actuator module. Needs high precision motors. Second is the control chip, which needs enough computing power to coordinate all the bots together. I really could manage 30 bots at once. But the base's network bandwidth is just too limited. If I try to control every single movement myself, the data load would crush the comms. So what then? Give each robot a local control chip with programs stored ahead of time. They just run their own routines. And I only need to sync up once in a while to check status, adjust settings, and send orders. That way, data traffic drops over 90%. So basically, the chip is the robot's local brain. You're just the remote commander. To be exact, I'm the mission planner and handle breakdowns. When it's running normally, they take care of themselves. My computer has a chip design database, but making them needs a lithography machine, which we don't have. What if I retrofit it as a laser cutter? Lay down the circuits on superconducting wire base, and laser etch circuit patterns directly. If the accuracy is not enough, stack more layers. If 1 isn't enough, then 2. If 2 can't do it, then 4. Basically building PCBs by hand. The performance won't be great, but it's enough. We don't need it for complex tasks, just to store a few thousand steps and handle 20 joints. The simpler, the more reliable. The chip integrates tens of thousands of logic gates, so it's enough to run offline alone. How many instructions can it hold? RAM is 6 KT, can store around 5,000 machine instructions. That'll handle a full mining or hauling routine. That's plenty. 2 weeks later, over 30 control chips finished. Ready to build robots. Let's do this. Simple, reliable, and duplicable. Doesn't need smarts. Just follow the plan. The first humanoid robot. Took a full 20 days to build. July 20th, first humanoid robot completed. Xiaoguang flashed the program. Base motion program uploaded. Task routine uploaded. Testing done. Motor control started and works fine. Joint delay is under 10 ms. Balance is steady. Let's give it a name. Number 001 is too boring. Let's call it Iron Pillar. Number 001 noted. Cody name. Iron Pillar. Iron Pillar is the base's first humanoid general-purpose robot. August 10th, fourth one named Iron Hammer. From the 5th on, completed bots. Joined the assembly line for new ones. Changxing split the assembly into 2 parallel lines. Line A, Iron Pillar and Iron Bolt. Line B, Iron Block and Iron Hammer. Both production lines started simultaneously. Every 5 to 7 days, 2 new robots roll off the line. Now we have an assembly line. On August 15th, robots number 5 and number 6 were finished together. August 20th. Robots number 7 and number 8 finished at the same time. August 25th. Robots number 9 and number 10 done at the same time. The manufacturing process is getting smoother. Parts supply is steadier now. By early September, 20 robots were already up and running. 8 of them focused on assembling new robots. All 4 production lines going full speed. We can finish 4 robots every 5 days. Robot number 24 done September 10th. Number 32 done September 20th. Number 36 done September 28th. By the end of September, the base had 36 humanoid robots. Chen Sheng assigned them different jobs. 12 robots dedicated to mining. They drive ATVs to mining sites every day. Use laser cutters to break up rocks. Load the ore onto mining carts and bring it back. 12 are focused on transport, moving materials inside the base, loading and unloading smelters, running back and forth to the warehouse. 6 robots operate the smelters. Automatic frame control for temperature and output. 6 run the machine tools and 3D printers. The whole process, Xiaoguang broke it down into standard steps. Mining robots collect ore, transport robots deliver it. In the smelting zone, transport robots bring materials to processing. Machine robots auto-process parts. Transport robots deliver parts to the assembly zone. Assembly robots handle pillars and bolts. Build finished products from parts. Between every stage, transport robots are moving materials around. The whole base runs like a finely tuned machine. Every gear moves as Xiaoguang directs, and Xiaoguang is the brain of the whole setup. This is a factory. September 30th, 2187. New calendar. Pioneer Base 1 enters automated production. Daily iron output, 120 kilogram. Copper, 30 kilograms. Superconductor, 2.5 kilogram. 80 standard parts, 0.3 robots per day. On average, 1 robot every 3 days. Now he has more time to think. No need to move rocks or cut metal himself. No standing by the furnace watching the temperature. All that work's handled by Xiaoguang the robot. Update, repair plan revised. Estimated completion, end of December 2187. By year's end, 9 months since the crash. It's no longer just one person's heartbeat. It's the pulse of an entire factory. If everything's done in sequence, it'll take at least half a year. No, not at this pace. If I keep going this way, I'd be stuck here 10 years. Gotta boost efficiency. Upgrade from manual workshop to mass production.
Huh.
July 15th, 2187. Pioneer Base 1 moved into the industrial phase. Daily iron output, 80 kilograms, copper 20 kilogram. Superconductor, 1.2 kilogram. 50 standard parts. Base rating goes from survival to industrial. Now. Officially starting ship repairs. Precision again. Every upgrade hits a precision limit. Current equipment max accuracy, 0.05 millimeters, 4 times less than target. Let's use low precision to make high precision. Climb up level by level. 3-stage precision upgrade plan starts. The iron rule of industrial progress. Use basic tools to make better ones. Then use them for even finer tools. It's a long climb to perfect accuracy. Precision, precision. It's the lifeline for survival. Every time we cast, we plant seeds of hope in the wasteland. Watching it take shape feels like watching faith become real. Every bit of weariness finds its home now. Inner diameter tolerance plus or minus 0.008 millimeters. Surface roughness 0.2 micrometers. Meets design specs. From this moment on, the base no longer needs to burn coal. The Swibian reactor is online. Output at 78% of rated power. Base power is now switched to the Swibian reactor. This compact fusion unit uses deuterium extracted from seawater to provide nearly unlimited energy. Good job. You can retire now. The day after the ALVBIEN reactor was activated, Morningstar finally had plenty of power. But he realized he'd overlooked something. The past 8 months, his quality of life was barely surviving. Food was rationed, dry rations and emergency meals. Now relying on plant starch gathered around the base, and small animals he hunted, his nutrition was off balance. Xiaoguang. Repeated vitamin C and trace element deficiencies. No stable hot water for hygiene. Bathing meant wiping down with cold creek water. Clothes were rarely washed. There was always a sweaty smell, mixed with metal dust. Poor ventilation in the base kitchen. Dust and fumes from smelting and processing areas. Sometimes drifted into living areas. I live like a caveman, but at least cavemen didn't smell metal dust every day. The ship's life support system is a closed-loop ecosystem, has 3 subsystems: water circulation, air cycling, and temperature control. Once repaired, the base would get stable. Clean drinking and utility water. Air quality would greatly improve, and there'd be steady hot water and heating. Repairs were simpler than the energy system. Most damage was leaky pipes and old filters. Changxing made a plan, carried out by the robots. Cargo robots scavenged pipes and parts from the mothership's wreckage. Fabrication bots made replacement parts on the line. The 3D printer made new filter cases. Changxing made new filter elements from ceramic membranes. It doesn't taste sweet, but compared to creek water, it's sweeter. The purified water has 0 aftertaste. Finally, I can breathe fresh air again. It's not about pleasure. It's something deeper. Hot water reminds him of Earth, and his mom telling him not to shower too long. Water's been steady for 23 minutes. Recommend keeping it under 30 minutes. Got it. This is just the first step. Just like last time when the lights came on. But this time, it's not resolve in his tone, but hope. I have no idea where I am. Xiaoguang, run the nav system's auto-calibration. Running, scanning all visible stars. Scan complete. Around 3,000 visible stars detected. But what? Match rate with known star charts is 0. I need to know where I am. I need to do astronomical observations. Identify the positions and spectra of visible stars. And cross-check with known star charts. Then calculate which galaxy I'm in. And my position in the Milky Way. How exactly? Step 1. Build an observatory. Equip it with a telescope and spectrometer. Step 2. Observe for several nights straight, recording location, brightness, and spectra of visible stars. Step 3. Use my computing power. Match the data to known star charts. Step 4. Triangulate location from matching results, and calculate my current position. Problem is, I don't even have a telescope. Then let's build one. Matching is slow. Of all observed stars, only a handful are found in known charts. That's all. They're all nearby, bright stars. But just a few stars aren't enough for accurate triangulation. Match rate is still too low. Just 12. Need at least 50 for location fix. Recommend more observations. Each matched star adds about 15% more accuracy. Up by 0.5 millimeter. Have the robot grind this spot a bit more. Passed. Beautiful. All right. Let's get to work. Changxing began observing for multiple nights in a row. Every evening after sunset, robots logged data for every visible star. Each night they recorded about 50 to 80 stars. Xiaoguang processed the data in real time, converted positions to celestial coordinates, and tried to match to known charts, like searching a giant puzzle for matching pieces. Still too few matches. Only 12. Need at least 50 to fix position. Keep observing. Each matched star adds about 15% to accuracy. During data review, Morningstar noticed something odd. A medium bright blue star. Its spectral features were almost identical to Sirius from known charts. Sirius is one of the closest stars to Sol, only 8.6 light-years away. Its spectrum is distinctive, and a 1V-type main sequence star. Surface temp around 9,940 K. Very clear spectral lines. If that really is Sirius, we can use it as a reference and backtrack our location. Spectral match 97.3%. Combined with 3 more matched stars. Let's use 95. Start a 4-point triangulation. Did it work out? The result could be awesome news, or terrible news, if we're close to human space. Say a few dozen light years, we can just fly back. But if it's far, like hundreds or thousands of light years, it'll be a near impossible mission. Nearly impossible. Calculation complete. Result? Using the parallax and spectra of 4 matched stars. Current galactic longitude 247.3 degrees. Galactic latitude about 12.7 degrees. Distance from the galactic center 8,200 parsecs. Checking. Converted. That puts us about 1,200 light-years from human space. For context, the Takwangji's jump drive, at max range, can cover about 50 light-years per jump. With the current engine and fuel, it takes at least 24 jumps to return, and would need 3 or 4 pit stops. Are there any way stations up ahead? Along this 1,200 light-year route, there are 0 known human outposts. The closest human station is in the opposite direction, about 400 light-years out. So basically, I have to travel 1,200 light-years non-stop. No resupply at all. With current tech, that's impossible. I need to boost the jump drive's efficiency and carry more fuel, or find refueling points on the way. 1,200 light-years. That number feels like a mountain on my chest, but I didn't break down. Any major problem can be broken into smaller ones. 24 jumps with no refueling stations. So we'll tweak the engine to fly it all at once. Or find a stopover along the way. Xiaoguang, save the coordinates to the navigation system. Then we need to reroute our way home. The base is running smoothly now. 36 robots are working under Xiaoguang's command. 12 mining bots are at the mining sites. 12 transport bots are moving supplies inside the base. 6 smelting bots run the intelligent furnaces. 6 machining bots are making parts by the machine tools. Changxing broke the problem into 3 layers. First, engine performance. The current jump engine design maxes out at 50 light-years per jump. Even at full power, it takes 24 jumps. So that's 24 precise navigation runs, calculations, and engine charging. Each jump needs cooling down and a checkup. Each jump takes about 2 to 3 days. Total trip is about 60 to 72 days. And that's if all goes well. Second layer, fuel for jumps. The engine uses antimatter as fuel. Pioneer's antimatter tank only holds enough for 4 to 5 jumps. 24 jumps would need 5 to 6 times our current storage. We'd need 5 to 6 times more fuel. Antimatter isn't something you just make. You need a particle accelerator and high-energy physics gear. That equipment is way more complex than what he can handle right now. Third layer, resupply. No human facilities along the route. If we could find a supply point en route, antimatter fuel or other resources, it would cut down a lot on how much fuel we have to carry from the start. But the problem is we have no clue what's out there. In the next few days, Changxing and Xiaoguang ran through all kinds of plans. Plan A, carry all the fuel at once. Make all 24 jumps with no stops. Problem, not enough fuel. Can't fit in the tanks. Plan B, boost engine efficiency. Cut down the number of jumps. If a single jump could go 100 light-years, we'd only need 12 jumps. 200 light-years per jump would be just 6. But that means rebuilding the engine, using high-temp superconducting coils instead of the old low-temp coils. Plan B would sharply boost energy containment. Plan C, find a supply point en route. Launch unmanned probes. Explore star systems along the route. Hunt for any usable resources or facilities. Plan D, a mix of B and C. Upgrade the engine, and look for supply points at the same time. Plan D is the best. Two-pronged approach. Engine upgrade is the base, while supply points are the backup. Decided to start with Plan C, build an unmanned scout ship. Send it to the nearest star system to explore. If we can find a supply point nearby, or any useful resources, the trip home gets way easier. Where is the nearest star system? The closest system is about 4.2 light-years away. A red dwarf star, spectral type M5V. Based on available spectral data, this star system may have 2 to 3 planets. Top speed for conventional propulsion is just 0.01 times light speed. It'd take 420 years to travel 4.2 light-years. Obviously, that won't work. We need much faster. If we upgrade the backup drive and use gravity slingshot, theoretically we could hit 0.05 times light speed. Still would take 84 years. Still not possible. So let's jump. The unmanned probe will have a mini jump engine. I know this takes a lot, but it's our only option. Design goal: build a small unmanned ship with the smallest possible jump engine and a set of detection equipment, able to jump to the red dwarf system 4.2 light years away, scan for planets remotely, and send back the data.
It's a big job.
But easier than fixing my own ship. At least it's unmanned. No need for life support. Step by step. Keep it as small as possible. As light as possible. As simple as possible. Main drive uses high-temp superconducting coils. Jump drive is the bare minimum. The tiny jump engine is the real challenge. It has to fit in a 3-meter hull. Needs a full redesign. Coil size is just 1/4 the original. Containment capacity drops a lot. "15 light years isn't enough. 4.2 will do." Wait, that's enough. 15 is bigger than 4.2. So just one jump. Messenger. Messenger. System check. Jump engine ready. Main drive ready. Detection equipment ready. COM system ready. Power system ready. Navigation set for target red dwarf system. Distance 4.2 light years. Messenger, launch. It may never come back from this trip. There's only enough fuel for one jump. Data return will take 4.2 years. Jump engine charging, 80%, 95%, 100%. Jump started. It's gone. Jump successful. It's now in a red dwarf system 4.2 light years away. Where's the data? Probe data takes time to collect. Signal return, 4.2 years. So over 4 years, we'll just wait. December 16th, Messenger launched. 3 days later, I realized I didn't know what to do with myself. The past 9 months, my life was on edge the whole time. I finished everything I could do. Now there's just waiting left. Waiting is the hardest part. I tried to keep optimizing the base equipment, but most improvements had already been pushed to the limit. I tried reading the novels on my databank, but couldn't focus. All I saw in my head was Messenger's jump. I even tried playing chess with Xiaoguang. Played 3 games, lost all 3. I'm no good at waiting. December 18th. I finally did something I've been putting off. Took 3 days to reorganize the Alien Encyclopedia into one format. Ironweed gave me my first gift from this planet, and it's the most precious one. The blue glow from the fluorescent bacteria beats LG. Solved the fuel problem. Blue shale is the backbone of all industry. Without it, there's no homecoming. 47 projects. 47 gifts this planet gave me. Suddenly, I realized, this planet isn't a prison keeping me stuck. It's home. It's been raising me. What I've learned here is more than 10 years on Earth, because there are urgent, real problems to solve here. Messenger has been flying for 12 days. On a mission 4.2 light years away, but he's here, waiting for results he'll learn in 4 years. I've been on this planet for 8 months. All I've thought about is how to get back. That hasn't changed. But now I want to bring something back, not just data and tech. I want to bring back understanding. I've learned what starting from scratch means. It's not having nothing. It's that everything is here, just waiting to be found. There's iron on this planet, copper, coal, superconducting minerals, grass that's stronger than steel, glowing fungi, fruits that make fuel. They're all here, waiting to be discovered. Maybe that's what I want to bring back. It's not about what I'd built here at Yixing. It's about what I've learned here. Waiting isn't wasting time. It's part of getting ready. This realization matches the concept of delayed gratification in human psychology. Your mental toughness index has increased 23% in 3 months. Stop scoring me, let's get to work. Maybe I'll find something new. Maybe it's just regular rocks and grass. But no matter what, I have to check. Because this is my planet. At least right now it is. What's wrong? Anomalous signal detected. From the routine monitoring system of the telescope. Signal coming from the same system detected before. An Earth-like planet, 300 light-years away. If its environment is truly like Earth, it could be an ideal endpoint. From here, first jump close to that planet. After repairs and checks, then jump the remaining distance, arriving at the Earth-like planet 300 light-years away. Then from there, head to human civilization 900 light-years out. The improved engine for the 900 light-year trip. If one jump can reach 200 kilometers, it would take 4 to 5 jumps. If 300 kilometers, just 3 jumps. But engine needs major upgrades, and we need to make sure that planet AD has usable resources, especially for antimatter fuel. 300 light-year distance. With current engine's max single jump, about 15 light-years. Need 20 jumps.
If Pioneer's fixed up,
Around 50 light-years. Just 6 jumps. No known stops on the way. So basically, I have to fly 300 light-years non-stop. No break. With current tech, Pioneer's fuel tank only allows 3 jumps. Should double that at least. Need bigger fuel storage. Need a more efficient engine. Need a bigger ship. Original Pioneer is too small. Fuel tank isn't big enough. Engine isn't strong enough. Equipment is not thorough enough either. I need a bigger ship, big enough for all the fuel. A stronger engine. Complete living and manufacturing equipment. Long space travel. Can't be weightless all the time. Need an artificial gravity system. Create a directed gravity field with room temp superconducting magnets. Simulate gravity inside the cabin. Need an anti-gravity system too. Can't rely on thrusters alone. They burn too much fuel. Use gravity wave interferer to make the reverse gravity field. That allows vertical takeoff and hovering. Also shields. Lots of micrometeorites in space. Heavy cosmic radiation. Make plasma shield with room temp superconducting rings. That shield should hold up. Artificial gravity system, anti-gravity and energy shield systems. All 3 rely on room temp superconductors. We currently have around 150 kilos of high purity superconducting material. Might not be enough, so we'll refine more. After all, homing ship is a big project. Each technology adds safety for the trip home. Every bit helps. This ship's name is Homing. Somewhere 300 light-years out. There might be an Earth-like planet waiting for me. And somewhere 1,200 light-years away is home. Tortoise. Pioneer was meant for close-range industrial jobs, not deep space travel. Its fuel tank is only good for 3 jumps. Engine's max jump is 50 light years. Hull structure can't handle the stress of many jumps. If it's used for a 1,200 light-year flight, it'll fall apart halfway. I need a ship designed from the start, just for long interstellar trips. But I can't build from scratch either. No shipyard, no big light ship processing equipment. So the most realistic plan is use Pioneer's core systems and build a bigger hull around it. Turn Pioneer into the core module of the new ship. Morningstar fully committed to Homing's overall design and climate control and life support systems, which are key for long trips. ECLSS system runs all temp controls and cycles, also grows crops inside the cabin, produces food using microbes and cell cultures. We'll be flying for months on the 1,200 light-year return. No surviving on compressed rations. Set a small greenhouse next to living quarters. Grow veggies, potatoes, lettuce, soy hydroponically. Choose kinds that grow fast with high nutrition. Add a cell culture module. Use reactor to grow single-cell protein. Boost protein intake. The whole system links with ECLS. Plants take in CO2 and make O2. Microbes process wastewater and organic waste. Creates a small eco-cycle. 3 support systems left. First, artificial gravity system. Superconducting gravity generator. 12 room temp superconducting magnet arrays. Couple gravity fields through strong atmosphere. Create directed gravity right inside cabin. Simulate 1G gravity, both living and working areas. All in gravity coverage zone. Total power use about 50 kilowatts. Watt. Second, anti-gravity system. 6 anti-gravity units. Each has 30-ton thrust. Total thrust 180 tons. Use room temp superconducting coil for gravity wave interference. Achieve vertical takeoff and hover near planet's surface. Total power about 120 kilowatts. Third, energy shield system. 12 shield nodes, spread across the hull. Room temp superconducting coil creates high energy plasma field. Forms a 30-meter shield bubble. Blocks micrometeorite hits and cosmic rays. Shield strength adjustable. Takes up to 500 mg of energy. Full power uses about 200 kilowatts. 3 systems use total 370 kilowatts. Add propulsion and life support, navigation, control, etc. Total power about 500 kilowatts. The improved mega reactor's output matches exactly. Just the right amount, no waste at all. But that's enough. Extra features include onboard manufacturing and repair systems. Astronomical observation gear and remote comms. Onboard manufacturing and repair need unique designs too. A journey of 1,200 light years. No supply stations along the way. If the ship breaks down, there's nowhere to fix it. So for the homecoming, it needs full self-sufficient manufacturing and repair. A manufacturing bay is set up in the ship's middle section, equipped with a small smart smelter, a precision machining bed, and a 3D printer. Stocking enough raw materials. Metal ingots, superconductor, electronic parts, sealing materials. If anything wears out or breaks along the way, just make replacements right inside the bay. Plus, the bay can also produce consumables, like parts for the bioregeneration system, pipes for hydroponics, even clothes and daily stuff. On a long voyage, self-sufficiency is key. Zhao Guang did the math. The equipment list and materials for the bay. Based on current industrial capacity, the bay's configuration works. Material stock is recommended for 2 years, leaving enough buffer. In the design process, the toughest challenge was system integration. Compatibility between old and new systems. A ton of control software needs to be rewritten. Same with the interface programs. Changxing built a 3D model on the optical computer. He walked through it in virtual reality. Let's add a window here. Not for any function. Just to look at the stars while flying. Changxing had the system calculate every resource needed to build the Turtle Palace. Given industrial output now, all material prep takes about 3 months. Construction another 2 to 3 months, so 5 to 6 months total. Meaning, if all goes well, We'll finish by summer. A huge, rugged ship full of power. Looks like an ark made from whatever we could find. A patched-together space ark. He smiled. Just like he said when looking at the superconducting wire. Yeah, it's not much to look at. But as long as it gets me home. The Homecoming's construction officially kicks off. Building an 180-ton ship. Can't do it with just 36 robots. I need at least 120. The smart furnace keeps assembling robots day and night. Building the new frame. Changxing handles control chip making. Etches every single one by hand. Changxing reallocated tasks. The base became a real factory. He set up a strict work schedule. Worked 16 hours a day. The ship's keel is the first big build finished. About 20 meters long. Every weld done by hand. Inched along, weld by weld. At night, the whole base is lit in blue-white glow from the lake. Looks like a fireworks show. For the next 2 weeks, Changxing went all in on building the hull's frame. The main structure started taking shape. Beams and columns crisscrossed. The middle is totally empty. Feels like standing inside a whale's belly. This is my new ship. 25 meters long, 180 tons. Can fly 1,200 light years. Still a long way to go. Hull, engine, fuel tank, life support. There's still so much left, like seeing the wreck of the mothership when I crashed. But this time it feels totally different. That was despair. Now it's hope. Keep going. Tomorrow we start on the outer hull. Homecoming's build officially kicked off. Changxing came up with a strict work plan. 16 hours a day, 3 shifts. Morning, structural parts processing. Afternoon, hull assembly. Night, system install and coding. 120 robots, all coordinated by Zhao Guang. 30 mining bots dig up or at the mine. 35 hauler bots move the materials. 20 smelter bots run 6 smart smelters. 15 machining bots handle machine tools and 3D printers. 10 welding bots handle the hull welding. 5 assembler bots handle system installs. The workflow is intense and repetitive. Mining and smelting. Steel plates are cut and shaped. Weld and assemble the ship's keel. A 20-meter iron alloy beam. The first major structure finished. Changxing used the big furnace. Smelted iron non-stop for 3 days. 4 segments cast in 4 pours. Then out on the base lot. Welded all pieces together by hand. Over 40 meters of welding lines. Changxing did every weld himself, carefully, inch by inch. The lake's glow isn't obvious by day. But at night, the whole base is lit up blue and white, like a fireworks show with 0 audience. Feels like being in a whale's belly. 40 days of non-stop work took its toll. Changxing kept losing weight, dropped another 3 pounds. Calluses stacked up on his arms. Some skin split and bled. Sealed it with biogel and kept working. Running on a major sleep deficit, only getting 4 to 5 hours a night. Sometimes he'd just toss and turn on his mat. The pipes and screens made the loneliness worse. For months before this, he was buried in work. No time to feel alone. Now, with the same thing day after day. Welding in the dark, alone. Or eating. The only sound is Zhao Guang's voice. Loneliness just flooded in. I'm so done with being alone. Doing everything by myself. Even fixing my own welding torch. Cooking my own food. No one to talk to. This isn't a problem to solve, but an emotion to release. Finally, there's hot water. That's progress. Another day down. I'll be back. Not talking to anyone. Maybe it's to Earth. Maybe to family. Or that new Earth-like planet I've never seen. Or maybe just to myself. Changsheng seemed like a new man. His mood didn't really improve. He just pushed his feelings down deeper. No more complaining. No more sighing. Just working without a word. His moves got smoother and smoother. He even tried more complex welds, like vertical and overhead welding. Your welding skill is now at expert level. An expert on Earth would need at least 5 years as an apprentice. I did it in 11 months. But your health keeps dropping. You're 18 kilos lighter than when you crashed. Muscle mass is down 12%. Bone density dropped by 5%. Try to rest more and eat better. After I finish the homecoming. Still a long way to go. But we've come so far. Need a certain alloy. The alloy of all alloys. 92.5. Not enough. Brand new process. 3 tough problems. The melting point's way too high. Compressive strength is 1.5 times pure iron. Density is 70% that of iron. Elongation at 12%. Great all-around performance. Done. You can tell it's good just from the sound. Next, the purity of the superconductors. That's enough. Coating uniformity within plus or minus 2%. Magnetic pillar efficiency is 60% above design specs. Positioning error, 0.3 millimeters. Meets design requirements. Winding done. 6 sets of lead width. Took a full 2 days. All 12 nodes finished. Now, just what I learned here, now really turned into a skill. Ready? Go. Last cut. No checks missed. Structural integrity test passed. Zhao Gang's naming ceremony done. Recommend recording build log. Homecoming. The next step is installing the core. Where do we start? Start with the virtual reactor. It's the backbone of the power system, and the most valuable part. Be extra careful when disassembling. How long will this take?
10 days then.
But not less. Next, cut the connections. 4 coolant pipes, 2 main power lines, 6 control cables, 2 fuel rods, 14 lines in total. Final step. Pull it out. Go. Slow down even slower. Step 1 done. Next up, navigation computer and jump engine. You saved the day. Now it's time to give your organs to someone else. That's it. Here. That's the top. The protocol's wrong. Navigation computer uses the old protocol. Hull control uses the new one. They need a translation layer. Here's another problem. Jump engine control signal delay is too high. There's a 0.5 second lag between command and engine response. During the jump, a 0.5 second delay could be a disaster. Full system debugging starting. Life support online. Closed circuit nominal. Navigation system online. Star map loaded. Jump engine on standby. Charge system nominal. Hull control system online. All rudders responding normally. COM system online. Long range COM lines deployed. Matter constraint system online. Containment field stable. Artificial gravity on. Test window magnet cracked. Output stable. Simulated gravity 0.98 g. Anti-gravity system online. Testing thrust 180 tons. Ship hovering steady. Shield system online. Shield strength test 100%. Energy usage 200 kilowatts. Full system test passed. Homecoming is ready to go. All done with loading. 3 more crates of samples left, including zinc or luminescent fungus and fibergrass samples. Oily fruit samples. Load them up. They're all treasures. Bring them back for the science community. Let them see how unique this planet is. Why make 3 backups? Because this is the first complete alien survival record in human history. It's as important as the silicon. What if something happens to the homecoming? 3 drives are in the bow, midship, and stern. Even if the ship breaks apart, at least one will survive. You really thought it through. I'm an AI. Being thorough is my basic function. June 13th. Every screw here remembers our warmth. But that warmth always fades. Goodbye, my stars. And thank you for taking me in. Finally, I can breathe. Someday, someone will use this to see a sky we never saw. Hello. I don't know who you are, or when you'll arrive. Maybe in a year, maybe in 100 years, maybe never. But I still want to write this letter. My name is Chen Xing. Star date, March 15, 2187. My ship, in a jump accident, was swallowed by a wormhole and crashed on this unnamed planet. I've lived here for more than a year. This past year, I learned to smelt iron, build steam engines, and make a base. Made superconductors, a telescope, and the ship. I met a flame beast. Found gold and silver. Built a factory. Built a ship called Homecoming. No intelligent life here, but it gave me everything. Minerals, water, air, and challenges. It turned me from a daydreamer into someone who could actually build things. If you crash here too, don't lose hope. This planet can support you. It's got iron and copper, coal and grass stronger than steel, glowing fungus, fruit for fuel. You'll learn to get along with it. And it'll teach you a lot. If you're just passing through, please stop and take a look. Check out the purple bush, the blue glowing fungus, and twin moons rising at night. It's beautiful, just takes time to see. I'm going home now. No idea if I can cross 1,200 light years. But I'll try. Morning Star. June 14th, 2188, new calendar. Zhao Guang's plotting the course. Destination, Earth. Route set. Total distance, 1,200 light years. Requires 3 jumps. First jump target. A G-type system 300 light years away. All systems standing by. Launch sequence ready. Let's set out. Finally heading home. Goodbye, my second home. Set the jump target. First stop, a G-type system 300 light years away. Navigation parameters entered. Jump engine charging. Estimated charge time, 4 hours. 4 hours. Let's go. Jump engine fully charged. Energy at 100%. Spacefold generator ready. Superconductor coils normal. Temperature stable. Target confirmed. A G-type system 300 light years away. No stops on the way. Estimated jump time. Based on engine and distance parameters, jump will take about 47 seconds. 47 seconds. Jump sequence start. 19, 87, 6, 5, 4, 3, 21, jump. I can hear my own heartbeat. I hear every tiny vibration in the ship. I hear Zhao Guang's countdown echoing. But all these sounds feel like they're coming from far away. Like there's something in the way. Structure integrity is good. Engine is nominal. Superconductor coils are stable. Containment field stable. Interaction systems nominal. Load bearing capacity, 12 OMG. Within safety limits. Lunar shift complete. Arrived at target star. Edge of system is about 2.8 astronomical units from target star. Lunar transfer took 47.3 seconds. All systems are normal. Success. Step 1 of return sequence complete. Xiaoguang, scan this star system. Check how many planets there are. Scan detected 4 planets. First, rocky planet. Distance from star, 0.4 astronomical units. Surface temperature is too high. Second, rocky planet. Distance from star, 1.1 astronomical units. It's in the habitable zone. Atmosphere and signs of liquid water detected. Third, gas giant. Distance from star, 3.20. Fourth, ice planet. Distance from star, 8.7 astronomical units. Initial analysis of the second one. The environment of the second planet is highly similar to Earth. Exact parameters need close-up probing to confirm. Earth-like. Returner. Heading to the second planet at normal cruise speed. Course set. ETA. 14 days. Artificial gravity system is working fine. Superconducting magnet and vibration output stable. Simulated gravity. 0.98 g. Shield system blocked 137 micrometeoroid impacts. Hull is undamaged. Wait. You just said there's no intelligent civilization signal. But during previous observations, that anomaly from the pulsar we detected was from this direction, right? The previous anomalous pulse was indeed from this direction. But after a full electromagnetic scan, nothing was detected. No active signals from intelligent civilizations. Then what about that anomaly? Reanalyzing now, the anomalous signal didn't come from the planet's surface. Signal source was about 200 kilometers above the North Pole orbit, or used to be there. Now the source has moved to the planet's surface. A man-made object detected, descended from orbit to the planet, onto a large island near the North Pole. Object has metallic structure, about 200 meters long and 80 meters wide. Should we go check outside? Radiation levels normal. Temperature, minus 215 degrees. Air is breathable, but it's cold. Suit up for warmth. Light guide analyze these symbols. Xiaoguang analyze these symbols. Analyzing. These symbols show a systematic structure, distinct grammar features. This isn't just decoration. It's script. A totally unknown writing system. Alien script. It really exists. Alien civilization. Let's go in. Proceed with caution. Interior structure is unknown. There might be danger. What is this? It's an information storage device. Its internal structure shows highly ordered nanoscale arrangements, like a massive data drive.
Its data density
Is about 100,000 times beyond humanity's best storage tech. 100,000 times. So that means this holds all the knowledge of their civilization. Most likely. Is this civilization still around? Judging from the outpost's condition, equipment aging, energy leftovers, dust buildup, suggest the outpost has been abandoned for at least tens of thousands of years. Whether the civilization still exists is unknown. Can we read the data in this storage device? It'll take time. Its data format and coding are completely unknown, but its underlying physics has something in common with human technology. If I get enough time to reverse engineer it, I might figure out some of it. How long? Roughly 2 to 3 months. Then let's take it slow. Even across billions of light years, there's an answer. If we use this principle on Returner's jump engine, the one jump distance could go from 400 light years up to 600 light years. So the remaining 900 light years home will only need 2 jumps. Finally finish the upgrades. Hope everything goes smoothly from here. Who are you? Where did you go? Going home isn't just about returning. He went back with a gift from an ancient civilization. Not the technology itself, but the possibilities. This knowledge proves something. Civilizations in the universe can go far and reach high. Humans weren't the first, and won't be the last. Let's go. Go home. All systems ready. After this jump, we'll enter human territory. Long-range communication system. We'll start scanning human frequencies automatically. So basically, we might contact humans soon. In theory, yes. Humans. Go, it's the third jump. Detected an artificial signal. An automated navigation beacon. Frequency matches human standard comes. Signal says, Human Joint Exploration Bureau, 7th Frontier Exploration Area. HD 187,234 Beacon New Calendar Year 2179. Star Tier Deployed, 2179. 14 years ago. This beacon's been running for 14 years. Signal confirmed stable. Means the outpost's infrastructure might still work. This report matters a lot, not just to let science know what I found, but to show them what one person on an unknown planet can do. Detected comes, multiple sources, human standard frequency, human united communications protocol. How many sources? 17 spread out in different directions, including merchant comms, military encrypted comms, civilian broadcasts, navigation beacons, SOS signal sent. Using standard emergency channel, distress signal, sent unknown spaceship detected. This is the Human United Patrol Ship Great Wall 7. We've received your distress signal and locked your position. Please report your identity and situation. Repeat, please report your identity and situation. My name is Changxing.
I'm back.
Changxing. Great Wall 7 has received. We're approaching you. Please maintain your current course and speed. We're coming to bring you home. So you are Changxing. That's me. Captain of Great Wall 7. Lin Yuanheng, welcome back. Changxing, your distress signal has been sent to Human United Headquarters. You know you've been missing for over a year, right? Over a year. Feels even longer than that. Turtle Shell arrived at the nearest human space station with Great Wall 7 escort. Reached the nearest human space station. Polaris Space Station. The data Changxing brought back shook the science world like an earthquake. 1-star encyclopedia, 47 degrees. Now expanded to over 80. Full ecosystem records of that unknown planet. Mineral resources and usable materials. It's the first time humans got a complete database of a primitive life planet's entire ecosystem.
Data.
Superconductor extraction process. Full documentation for molten salt layering method. Future of room temperature superconductor applications. Materials scientists went crazy. Design and construction records for the Gui Kang ship. One person in over a year. On a primitive planet. Built a starship from scratch. This achievement's an engineering miracle. And the most explosive ancient alien civilization. Outpost data. Alien star maps. Spatial folding efficiency optimization principles. Improved antimatter storage plan. The academic value of these technical docs is beyond measure. After the Human United Academy got the data, they held an emergency meeting. Scientists' feedback was just one word: revolutionary. What's on your mind? Thinking about that planet. I left a data pod when I left. Not sure if anyone will visit in the future. Someone definitely will. The data you left is way too valuable. That planet will be a scientific reserve. And the outpost. That ancient civilization. Where did they go? They're way more advanced than us. But their outpost got abandoned. A civilization that can do spatial folding jumps can't just disappear easily. They have to be out there somewhere. Do you think humans will ever find them? Not will find, it's definitely will. We'll find them for sure. Where's the next stop?